we come to the third, where we ask to ourselves that what control the deposition behavior of liposome and can we effectively manipulate that using liposome number concentration in suspension and diameter of liposome. So over here we prepared the liposome using extrusion technique. So we extruded them with 50 nanometer size. We observed that the liposome size in suspension is about 140, and again we extruded with 400 nanometer size, where we observed the liposome size in suspension is 250. So these are flexible kind of particles, whereas this liposome has a different cladding of lipid layer. So you can see a multilamellar sort of structure. However, this is a partial assurance that this is a multilamellar structure. We have other techniques which we are employing at present to confirm that these are multilamellar structure and these are unilamellar structure. So a case study with 250 nanometer size liposome is as follows. So we see that when we have a very less lipid concentration or very low liposome number concentration, it corresponds to probably 1 particle per droplet, which result in a dry particle size distribution of 91 nanometer. Whereas when we have inclusion of multiples of these particles in a droplet, it ends up in a higher mobility diameter. So it shows that the inclusion of multiple or manipulating the lipid liposome number concentration can effectively change the particle size distribution, which is a potential advantage for inhalation drug delivery of the particles. So I will conclude with these 3 conclusions, intermediate conclusion at present, which is liposome rupture and probably not fusion is leading to leakage. Second is monodisperse aerosol generator like electrospray generates bimodality due to 2 different agglomeration pathway. Aerosol size can be manipulated by liposome concentration in atomizing suspension, and airborne aerosol it retains its hollow spherical structure and do not collapse. I would like to acknowledge our collaborators and my colleagues from the lab which I belong to, Particle and Aerosol Research Laboratory at IIT Bombay, and this project had been supported by CRNTS, it's a DST body at IIT Bombay, Indo-US Science and Technology Forum and US Fulbright Foundation. And this is a clip from our lab. Thank you so much for your audience. And I would like to have any questions if you have.
Yes. Yeah, so that why do you get that bimodal drop size distribution?
What happened is at this point, at this point there are 2 different aggregation pathway. Now the instrument which we are measuring is called as the mobility diameter, which takes into consideration the diameter of this particle. So
when you report the diameter, which diameter? Is this the maximum dimension you are talking about?
This diameter. This diameter. So this is the diameter is 1 and this diameter corresponds to 35 nanometer. This diameter corresponds to 100 nanometer. So the pathway of aggregation is head to tail like chain in one case giving to 35 nanometer, and the other one is side by side. So this liposome get distorted and form like cylindrical structure.
So is this one double of the other value? Is this side to side?
No, it's not the double of the other value. It's a good question. I don't have an explanation of 35 or 100. But what I can feel, because this is a soft particle, is very difficult to establish sort of established based upon the surface area or something like this. Are not hard particle, this is a soft particle. So we observed a number of images on the TM image, and we observed that the mean particle size is around 100 nanometer as far as this thickness is concerned.
So maybe you have more than 2 actually getting stuck side by side, not only 2.
Well, our result from here shows that we have 2 diameter. So we pulled up the particle corresponding to this diameter and corresponding to this diameter. So this shows that the particle size is basically clustered into 2 populations, one centered around 35 nanometer, the other around 100 nanometers.
Okay.
Thank you.
Any other questions? Okay, so let's thank Saptarshi once again.